Okay, welcome back to Calculus 2. We are going to work on a couple more work problems, pumping water or fluids out of a tank. And we'll go ahead and take a look at this one. So we have a hemispherical tank, semi-spherical tank. Okay, semi-spherical tank of radius 5 feet is completely filled with water. Calculate the work required to pump all of the water out of the tank. Okay, so let's go ahead and draw us a little picture. So we've got a hemisphere here. Okay, pretend that's round. So we're going to be able to say that this little piece here is 5 feet. Okay. This piece down here, 5 feet. Okay. And we can go back and say, okay, we need circles. So going back to my college algebra, we can say x squared plus y squared is equal to 25. That means that y is equal to 25 minus x squared, square rooted. Conversely, x equals 25 minus y squared, square rooted. Okay, so we go ahead and figure out that. Okay, so again, the same idea for the work is we have work is equal to force times distance, and we'll just integrate that as we're going to be able to deal with it. Okay, and our force is going to be, so force is equal to rho times my volume. Okay, so that's kind of what we're looking at for that. Okay, so for this case, it's going to be a changing kind of a thing. So if I take this little slice down here, my radius is kind of small. If I take it up here, it's going to be a little bit different. So we're going to be able to say, okay, um, what if we did this and I picked this thing here and I rotated this curve? You'll say rotate this little curve here. We'll keep it as y. We'll say we're going to say x equals 25 minus y squared times dy here. Okay, so we're rotating this thing here. Okay, so we're going to say we have pi, and now we're going to take our square root of 25 minus y squared, and we're doing method of shell, so that's going to be squared dy. So we'll have a little dy sitting here as we rotate it around. Okay, so we've got that little piece here. Okay, so let's go ahead and we have 0. Let's go ahead and say we're going to say this is going to go from -5 to 0. Okay, -5 to 0. And then we're going to say that we have rho or r squared. So this is going to be the square root of 25 minus y squared squared. So that's my pi r squared. Here's my dy, right? And I moved it over because I want to have a 5 minus y for the fact that I'm pulling this up out of the out of the tank. Okay, so that's what we're going to be dealing with that. All right. So there we go with that. All right. So let's see here. Yep, we're looking at this. Okay. So let's go ahead and square this. So we're going to say we need a rho times my volume. I put the rho on the outside of the integral because it's constant. It's still 62.4. Again, this will be given to you. And it's pounds per cubic foot. Okay, pounds per foot cubed. Okay, pi. And then we have our -5 to 0. Here we have our 25 minus y squared. I squared it times 5 minus y dy. And we have to go ahead and figure this thing out. So let's go ahead and sort this out. So we've got 25 times 5, that's 125. So that's the first bit here, minus 25y minus 5y squared, that's this piece here. And then plus y squared times y is going to be y cubed. And we're integrating between -5 and 0. Here we have our 62.4 pi as we sit out in front here. And then all of this stuff here is times dy, of course. Okay. So let's go ahead and integrate. So we have 62.4 pi. Oh, we're integrating, so I don't need to write this anymore. Okay, so here we go. And we're going to say this is going to be 125y minus 25y squared over 2 minus 5 over 3y cubed plus 1/4 y to the fourth power. Okay. When I plug in 0, everybody turns into a 0. So we have 0 minus. So we have 0 minus. And then we're going to say plug in our -5 here. So we have -125 times 5. Okay, I'm going to beat you to the punch there. 125 times 5, I know that's 5 to the 4th, but it's going to be 625. So that's going to be a negative, draw here, 625. The 5 squared is going to be negative. Squaring is going to make positive, so we still have a minus 25 times 25 over 2. So I'm going to say it's 1/2. If I plug in my 5 here, it's 5 squared. So it's 25. 25 times 25 is 625 minus. So this is going to be a -5 times all of this stuff. So this is going to be a negative times negative. So we're going to have a positive in here. So here we're going to have 125 times 5 is 625 over 3. Okay. And then finally we have a plus. And then -5 raised to the 4th power is going to be positive. So we have 1/4. And of course we have 625 on the top there because we have that little thing going on. Okay, let me go ahead and distribute my negatives. So we have 625 plus 1/2 of 625 minus 1/3 of 625. And then we finally have a plus, that was a minus this guy. And then we finally have a minus 1/4 of 625. So fortunately, look at this. 625 is all the way here. So we have 1 plus 1/2 minus 1/3 minus 1/4. Now let's see what that gives us. Okay, so we can go ahead and look at that. So we have 1. Let's go ahead and do this. We have 1 plus 1 over 2 minus 1 over 3 minus 1 over 4. Okay, equals, and then we're going to do something fun here. I'm going to say second function. I'm just going to go to math, and I'd say I'd like to see it as a fraction instead. Okay, so it's 11/12. So we have 625 times 11 over 12. What do we have here? We had this 624, 62.4 pi out is in front here. So we're going to say this is times 624. No, that's not right. 62.4 times pi. There we go. 62.4 times pi. And that's going to be our whole answer here. So we'll leave the pi's out of it. So we'll just go ahead and calculate this. So we'll say this is going to be 62 or 625. 625 times my 11/12. I'm just going to type in answer. That's my 11/12 times my 62.4. I will leave the pi on the outside there. That'll give me 35,750. 35,750 pi foot pounds. Okay. And that would be a nice answer for that. Give me a moment. I'm going to go dial up another problem for us. Okay, here's our next problem. So here we have a cylindrical tank that has a radius of 3 feet, a height of 8 feet. It is partially filled with water up to 5 feet. How much work is required to pump the water out of the tank? Okay, so again, I'm going to say work is equal to force times distance. I'm going to integrate over that. So we're going to say we have rho times V, okay, times our distance. Okay, just to kind of think about how to set this guy up. So fortunately with this thing, it's a cylindrical tank. The radius isn't changing. So even in a cone, it would be changing a little bit, but this guy is a constant radius. We don't have to worry too much about what's going on here. So we're going to have our dy here. So my cross-sectional area is always going to be pi r squared. So we have, here's my volume. So we have 64.2. Okay, that's my density part of this thing. Our volume is going to be pi r squared, so it's 3 squared times the height, which is going to be my dy here. And then the distance that we're going to be dealing with is going to be 8 minus y, because this whole thing is 8 feet tall. The water only goes up to 4 feet, right? But the whole thing is going to be 8. So the distance is still going to be 8 minus y for push it. How far do I have to push it? Right? We're going to go ahead and do the whole 8 feet minus the y there. So here we go. So we have, let's see here, we have 64.2 times 9 times pi integral. Now, we only have to go for all of the water. We're only going to go from 0 to 5 sitting here, right? Because it's going to be, it's only up to 5 feet. So we'll go to 0 to 5. Okay. 0 to 5. Let's see. I think it's just 8 minus y. Yeah. Dy here, because the other parts of this were constant. So this is what we're going to be able to do here. Okay, so let's see. We have 62.9. Now we have, let's go ahead and turn you on here. 64.2 times 9 times pi equals 577.8 pi. And here we're going to say this is going to be 8y minus 1/2 y squared going from 0 to 5. All right, so we can go ahead and plug that in. So we have 577.8 pi times, and we have 8 times 5 minus 1/2 times 25 here. Okay, so we have 40 minus half 25. We'll go ahead and get the calculator out for that because I'm going to be lazy. So we have 40 minus 0.5 times 25. Yeah. So we'll say, okay, it's 27.5. So we have 577.8 pi. Okay, times what was the value I just had for that one? 27.5. 27.5. And we'll go ahead and calculate that out and we say, okay, that's our answer. So 27.5 times 5/7. Oh, that's not good at all. Delete. Okay. 27.5. There's my point. 5 times 577.8. Okay. So we have 15,889.5. 15,888. Let's double check that. 15,889.5 pi foot pounds. And that would be our answer for this guy right here. Okay, so that's a pretty good sort of spectrum of the kinds of questions that they have there. There could be harder ones, but I know that setting these things up is kind of a difficult thing. And the point is not to defeat you. The point is like to see if it can challenge you for something. So I'll go ahead and say this is a good part of the video. And thank you very much for watching the video, and I'll see you in the next one. Thanks. Take care.